this video, we'll be covering how to sketch parametric curves. Here you can see x and y given by the following expressions. But when we see those, at first it might seem confusing, but let's recall the formula for a circle. So the formula for a circle was the following. So basically x0 and y0 are our centers for the circle, and if we have a circle that is centered at 0, 0, then those will simply be replaced by zeros, and we'll be left with an even simpler formula. So now let's plug into this formula and see what happens. So hopefully we'll get something out of that. So now I'm simply plugging in those values into their corresponding variables. So I will now have r squared cosine squared theta plus r squared cosine squared sine squared theta. And now let's factor out r squared. So we will be left with cosine squared theta plus sine squared theta, which, as we know from trigonometry, will be equal to 1. So we'll be left with r squared. So basically, the following parametric terms will give us a circle with radius r. So suppose this is our circle and this is our radius. So this is how we sketched those two terms. Now we are given another curve with x being equal to 2 cosine theta and y being equal to 5 sine theta. Now let's try out the same expression, the same formula, but in this case we will see what happens next. So you see, if I square them both up, I will have the following result. And if you might recall, the formula for an ellipse would be given in this form. B squared equals to 1. So now let's transform this and let it be equal to 1. In order to transform this so that it will be equal to 1, we will need to divide them by 4 and 25 respectively. So what we have over here is that we will have our semi-major of the ellipse on y-axis with the length 5. So this is 5, this is minus 5. I'm just sketching the half of the ellipse. I will be sketching the other half later. So, and then we will have 2 over here and minus 2 over here due to our 4. So basically on y-axis we obtained our semi-major, and on x-axis we obtain our semi-minor, and we have this ellipse.